Imagine sending your identical twin on a spaceship traveling at 99% the speed of light. You stay here on Earth. They travel for what feels like 10 years, then come home. When they step off that ship, they haven't aged a day. Meanwhile, you're a decade older. This isn't science fiction. Einstein's math says it's real, and we've actually measured it.
Today we're solving the twin paradox, one of relativity's most famous thought experiments. But here's what makes it interesting. It's not actually paradoxical. The real lesson is about acceleration, about reference frames, and about something unsettling. Time isn't what you think it is.
Let's start with what Einstein actually discovered. Time is not absolute. The faster you move through space, the slower you move through time. This isn't metaphorical, it's measurable. In 1971, physicists Hafele and Keating took atomic clocks aboard commercial aircraft flying around the Earth. When they compared those clocks to identical ones left on the ground, they found the airborne clocks had ticked slightly slower. We're talking nanoseconds, but they were measurably, verifiably younger. GPS satellites prove it every single day. These satellites orbit Earth at about 14,000 kilometers per hour. At that speed, time runs about 38 microseconds slower per day than it does on the ground. But Einstein also predicted something else. Gravity slows time too. Inside a satellite, gravity is weaker. That effect actually makes time run faster. Both effects combined, they have to account for them, or your phone's location would drift by kilometers in just hours. Relativity isn't optional, it's infrastructure. Okay, so moving clocks run slow. That's time dilation. But here's where people get confused. If your twin is moving at near light speed, why aren't you also moving from their perspective? They see you moving backward. So shouldn't both of you age slowly? This is the paradox, and it seemed to break Einstein's theory.
The resolution is acceleration. The traveling twin doesn't coast at light speed indefinitely. They accelerate away from Earth, coast, then decelerate to turn around, coast back, and decelerate again when landing. Those accelerations, the changes in direction and speed, break the symmetry. During acceleration, the traveling twin experiences forces that the Earth twin does not. General relativity tells us those accelerations actually do something profound. They change which moments on Earth correspond to now for the traveling twin.
Think of it this way. During acceleration, something strange happens to simultaneity. Imagine events that were simultaneous for the traveling twin at the turnaround point. From the traveling twin's new reference frame, Earth has experienced months or years of aging instantaneously. They haven't slowed down during this moment. Earth has jumped forward in time. It's bizarre. It's real. And it's because now is not universal. It's relative to your motion. The math works out perfectly. Time dilation is real. Acceleration resolves the paradox. And here's the existential kicker. If you actually travel to Proxima Centauri, our nearest star, at 99% light speed, it would take about 4.2 light years in Earth time. From your perspective, the journey would feel like a few months. But when you returned, everyone you knew would be dead. Centuries would have passed on Earth. You'd be younger than people who were born after you left.
Here's a bonus. Muons are subatomic particles created when cosmic rays slam into Earth's atmosphere. They decay in microseconds, so they shouldn't reach the ground. But they do, because from Earth's perspective, they're moving so fast that time slows down for them, and they live just long enough to reach us. From the muons' perspective, Earth's atmosphere is compressed so thin they zip right through. Both perspectives are correct. That's relativity. The twin paradox isn't a flaw in physics. It's a window into how space and time are woven together, how acceleration matters, and how the universe is far stranger and more interconnected than our everyday experience suggests. Subscribe. New science every week.